Hello, 516 students. Today we're going to be going through EFR 516 online, a logistic regression example. So number one asks, um, run an ANCOVA with the below data, predicting graduation from school and the two covariates, variable one, variable two. Is there a difference in the graduation rates between schools? Write up your results in APA. Okay, so what we want to do is test the difference between schools. For example, does school one have a different graduation rate than school two versus school three? And we have two covariates. So for example, we're working with an intelligence test and we're going to test a population, but for example, children are going to be in there. So we know they won't do as well as adults. So you could have age as a covariate, and that would be correlated with the dependent variable. So we just have two covariates in the model, and what we want to do is this form a statistical control. So now also too, we see an issue over here. Graduated is 1 or 0, either graduated or they did not. And we know that's not continuous, so actually that's a violation of the assumptions, but just for demonstration purpose, we're going to run what we're going to do here. So we'll bring this data into SPSS, and then we'll run the analysis. So we're going to go Analyze, General Linear Model, Univariate. Analyze, General Linear Model, Univariate. Then we're going to bring graduated over to the dependent. Then fixed factors, that's school. And then of course we have our two covariates. I'm going to go ahead and ask for a plot. And we're going to bump school over. And we're going to add that for a plot. Then we're going to press continue. Okay, so I'm all ready to run the analysis. So I'm going to paste it into my syntax window. I'm going to go down to the SPSS icon and click on that, and that's going to bring up my window. Now the first time you paste, the window will come up automatically, but after that it will not. So now I'll go ahead and block it, and then I'll run this analysis. Okay, so we see the graph and of the different schools. So school one's the highest, school three's the lowest. The question is, we know that there's a difference in the sample, but what do we think about the population? To do that, we're going to go ahead and bring these tables over and then interpret these. So you can bring the graph over too. So what we're looking at here, what we're interested in is right here, school. Okay, so it's an F test. It has 2 and 25 degrees of freedom. Its value is 0.207. And as we see here, the p is greater than 0.05. So I'll go ahead and write that up. And so here's for school. Here's my APA. And my conclusion, no evidence of a different graduation rates between school and the population. So we failed to reject the null. We don't have any evidence. So, but one thing that when we look at the assumptions of an ANOVA or ANCOVA, we see one of the assumptions is of normality. And we fail that right here. Here's a plot of graduated, our dependent variable, and we see it's a binary. It's either 0 or 1. 1 being graduated, 0 being not graduated. So that's trouble for us. Now, the actual concern is of normality of the errors, but if we don't have normality in the dependent variable like this, we're going to have trouble in the errors. Okay, so one way to get around this is to run logistic regression. Binary logistic regression, meaning binary 0 and 1, for example. Now, there's some information about logistic regression and how we come about that analysis. This is similar to what we'll find in the book. So if you're interested in that, you can look at that and read that. So here we're at number 2, and it says run an logistic regression with the below data predicting graduation from school and the two covariates. So same analysis, but this time we're going to run logistic. Now it's showing you the individual steps here and what that should look like in that analysis. Now it's the same data, so you don't have to bring in new data. So I'm going to come here, I'm going to go Analyze, Regression, Binary, Logistic. I'm going to click on that. I want to bring my graduated over to dependent, and I have my three variables here. I have my main variable, which is categorical, and I have my two covariates, which are continuous. Now, because school is categorical, I'm going to come over here to the categorical button. I'm going to press that, and then I want to move school over here. Now, we're just interested in what we'd call the omnibus test. Is there any difference in the schools? But then you can look at the individual comparisons down here. Now, when it does that, it's asking for a reference. Let's pick school 1 as the reference, the first one. But we're not so interested in that. Okay, so I've got my school here. I'm going to say continue, and I'm ready to go. So I'm going to go ahead and paste this. I'm going to go to my syntax window by clicking on SPSS icon. I'm going to block that. I'm going to run that. Okay, so you get quite a few tables out here. You don't really need them all here, but I brought them over anyway. There's information in there that's interesting. So then I'll bring it to my Word document. And like when we do the ANOVA table, there's an overall omnibus test for everything. And we can look at that, and that's the omnibus test for the model coefficients, meaning is the model statistically significant? And we see the model by itself is not, but we're just interested in testing school. So we're going to go down to this last graph, and here's the individual covariates. So the first row here is the omnibus test for school. Then there's the individual comparisons, and then there's the two covariates. Now we see our two covariants are not statistically significant, but they're still accounting for some of the error in the model, so we'll go ahead and leave them in there. So we want to write up school here, and so it's a walled test, and its degrees of freedom 2. We're not statistically significant because the sig is not less than 0.05. So we see here that schooled wall p greater than 0.05. So our conclusion is no evidence of different graduation rates between school populations. So basically we're getting the same results as we did in COVA, but here we're abiding by the assumptions of the test here, which is for our logistic regression. So this is a very important tool when you have that binary data and the output. Okay, thank you. You can go ahead and then do the assignment.